Okay, so simplifying radicals. Oh, simplifying radicals. Let's start kind of with this little rule here. It really helps me a lot. Um, it says this, that if we have square root of AB, then it is the same as the square root of A times the square root of B, and that's true as long as the indexes are the same. Here's an example of that. Maybe take the square root of 16. Now I could do this, but I don't see how that would help much. Can't say that would help me at all. But it is true because 8 times 2 is 16, and that would work, but it doesn't help. But what if I chose some factors of 16 that were more useful to me? Like the square root of 4 times the square root of 4. Well, 4 times 4 is equal to 16, so that does work. Why is that more useful? Because, well, first off, let's take this thing that we know. And what is the square root of 16? It's 4. And the square root of 4 is 2. I'm just doing this math here. And then this multiplication sign is this one. And the square root of 4 is 2. I just simplified that. And it is true that the square root of 16 is 4. And 2 times 2 is 4. Here's just another quick example, and then we're going to start to apply this rule a little bit. The square root of 36 is the same as the square root of 4 times the square root of 9. The square root of 36 is 6. The square root of 4, well, 9 times 4 is 36, just checking. Square root of 4 is 2, and the square root of 9 is 3. And 2 times 3 is in fact 6. So why do we care about this? Because it leads us to this. I could ask you this question. I could ask you to please simplify the square root of 12. And normally I would tell my students, you know what, the square root of 12 is the square root of 12, unless you can state it perfectly. But here we can state it a little bit better. Isn't it true? Well, this is what I'm doing. I'm looking at I'm looking at the 12, and I'm asking myself, does 12 have any factors that are perfect squares? And it does. It has 4. So the square root of 4 times the square root of 3. I'm going to check this math and make sure it works. 3 times 4 is 12. The square root of 12 is, I don't know what, but the square root of 2 is, the square root of 4 is 2. The square root of 3 goes back. It has no perfect squares as factors. So the square root of 3, I leave it as the square root of 3. So we can simplify the square root of 12 to be 2 times the square root of 3. Okay, so here are some problems that you saw on your homework. And I just want to kind of push through a couple of them and see what you think, okay? So here's one. Also, I realize that the square root of 9 is plus or minus 3. I'm not talking about that right now, kind of the absolute value idea. Just looking at this in a much more general way, so please forgive me, those of you technocrats out there who are going, you know what, you're missing something huge here. I get it. Y to the 4th. And we want to know what's the square root of that. Remember, this is a square root because the index, which goes right here, is blank. If the index is blank, we assume that it's a 2. So if you see the square root written as the second root, that's the square root. Or if you see nothing here, it's still the square root. So what I'm going to do is I'm going to rewrite this a bunch of different ways. Oh, look at this. I'm going to take my 24 and I'm going to say, well, 24 is 4 times 6. Isn't that true? And I'm going to take my x squared because it's this times this times this, isn't it? And I'm going to say this is the square root of x squared. And this is going to be really strange to you, but the square root of y squared times the square root of y squared. Remember, when we multiply like bases, we add their exponential values. So this times this would be y to the 4th. And what is the square root of 4? It's 2. I'm going to hold on to this piece just for a second. Just going to hold on to that for a second. The square root of x squared is just x. The square root of y is y. The square root of y again is y. So y times y is y squared times square root 6. All right, so that takes us to this next problem. Let's look at this one if you don't mind. Let's look at this one. the square root of 4x to the 6th y squared. And I'm asking you, what I would ask my calculus students is, how can you rewrite this? How can you rewrite this? So that's what I'm looking for. I'm looking for a rewrite, because if you can rewrite this, you can make it better for yourself. So the first thing I see is the 4 here. So I'm going to take the square root of 4. Second thing I see is this x to the 6th. X to the 6th to me is x squared times x squared times x squared. If you multiply these, x squared times x squared times x squared, you'll get x to the 6th back. Right? And then lastly, I see this, square root of y squared. Square root y squared. Well, what's the square root of 4? 2. Square root of this x squared is x. So all I'm doing is I'm answering these questions. So as I come down, I'm bringing the answer down. What's the square root of x squared here? It's x. This multiplication sign again is this one. What's the square root of x squared here? It's x. And what's the square root of this multiplication sign? Is this one. What's the square root of y squared but y? So we'll get 2x to the 1. So x to the 3rd. Y is our answer. Okay? All right. Okay. All right. Let's try just a couple more real quick. Okay. Now, hopefully, what you're doing is what you're supposed to be getting at is you're trying to break this apart. So I have the square root of 12. I'm going to do these colors. X. Surprised me a little bit. Y squared. So what do I see here? I'm going to rewrite this as 3 different problems. I'm going to rewrite it as the square root of this thing times the square root of this thing times the square root of this thing. And I'm breaking this up in ways that work. Ooh, I'm going to have to do more than that, aren't I? Yeah, can I take that back? Don't be mad. Don't be mad. Let me just deal with the 12 first. All right? I'm looking at the 12. Does 12 have any perfect square factors? It does. The perfect square factor it has is 4. So equals the square root of 4 times the square root of 3. This piece and this piece give me this back, doesn't it? Times the square root of x, but I don't have x squared or any versions of x squared, so I can't take one out, right? Times, now I want the square root of y squared. Yeah? So this 12 is captured 4 times 3. This x is captured here, and the y squared is captured there, isn't it? Now go back and start answering the questions. What's the square root of 4? Well, the square root of 4 is 2. What's the square root of y squared? I'm going to do this in some fashion. Is just y, isn't it? And the square root of 3 is just the square root of 3. And the square root of x is just the square root of x. So I'm just going to multiply 3 times x, and I'm going to get the square root of 3x. 3x. This 3 is that one, and this x is that one. Okay? All right. I think we have a good start. What you need to do, frankly, is keep practicing. This is a skill really worth having. It's going to pay off for you later, okay?